There's some other kinds of prompting. There's another very interesting prompting called COT prompting. And what I wanted to do at this point in time is to take you to one more very interesting link, very nice link, which talks about all these prompting techniques in a lot of detail. Let me take you to one more link here. All right, so this is the article actually. It's a pretty nice article. It talks about the different elements of prompting. The first part is very similar to what we talked about, and this is the part I was referring to. Zero shot, few shot, chain of thoughts, all the different types of prompting techniques are talked about here. And specifically, if you see, we have the chain of thought prompting, the few shot prompting here, and I wanted to just show this part to all of you, right? Yes, yes, I will do that. I will do that. Yes, yeah, yeah. I have all the links with me. I'll post it on chat in one go. Okay, so I'll post it on chat in one go. Don't worry. All right, so we have the few shot prompting, and let us see. So few shot prompting, we already saw what is the good thing about few shot prompting. We already talked about that. So the good thing is this, that you can give some more tailor-made examples. But what is the limitation of few shot prompting? What is the negative aspect of few shot prompting? The negative aspect is this. Look at the screen, all of you. Look at the left-hand side. The left-hand side demonstrates a simple few shot prompting example. And the right-hand side, to overcome the limitation, we use a different type of prompting technique called chain of thought prompting. So left-hand side, what you see is a simple example of few shot prompting. It's actually a reasoning-based question, and we are trying to solve it using a few shot prompting approach. It doesn't work. On the right-hand side, we are using something new called chain of thought prompting, where the reasoning is very clearly explained. So all of you take a look at it, give it a glance. I think everybody is able to understand generally that what's happening here is on the left-hand side, when we use few shot prompting, we are actually, especially for reasoning-based questions, you can see few shot prompting is not going to work well. Because the moment you have reasoning based questions, and if you just give input output examples, it doesn't really work. Because few shot examples is what? Few shot examples is just based on input output examples. You are trying to train the machine based on, you're trying to train the language model based on some input output combinations, based on some input output examples. That's what few shot prompting is, right? That's the idea. The few shot prompting is just based on the input output examples. That's the whole idea of what few shot prompting is. But the problem is when you have reasoning based questions, when you have reasoning based questions, just having the input output examples don't help. Okay, if I say 5 plus 8 equal to 13, I cannot just say, okay, input is 5 plus 8, output is 13, input is 7 plus 8, output is 15, but we will not learn anything from that. But what you need in these kinds of cases is you need the language model, and you need to understand, you need to explicitly understand how to go ahead and reason. So the reasoning part has to be more explicitly done. That is the whole idea. The reasoning part has to be explicitly done, and that's the whole idea of what the chain of thought prompting will do. So you can see on the right hand side, the reasoning part is more clearly explained. So the mathematics of how the solution has to be approached, the approach is more clearly explained, and which is also a big part of today. Nowadays you see a lot of reasoning models like the DeepSeek that was released this year, early this year. It was a reasoning model, very, very powerful reasoning model, and they're all inherently based on chain of thought prompts. So the reasoning part is very clearly explained here. That's the idea. You can see the right hand side. We are not only giving the examples, but we are also giving the reasoning behind the answer. So Roger has started with 5 balls, two kinds of 3 balls each. That means we should add. We have to explicitly tell. Don't just say answer is 11, but how did we get to the 11? That's the most important part. Okay. So this is the way chain of thought prompts actually work out. So same way, we do an example here. You can see system message is given, and it's a very detailed system message. But only difference is it's a much more detailed step-by-step approach. And oftentimes at the end, we also say, explain your reasoning behind the answer. So before you present the final answer, you please tell what is the reason why you gave that answer. So that is also a very important part of the message. Okay. Another kind of prompting that is very common is a rephrase and respond kind of prompting. It's actually quite simple. All that we try to do is based on the original user input. So based on the original user input, what we do, we rephrase the original user input. That is what we refer to as rephrase and respond prompting. Because you have to understand that the users, the original users, when we talk about the users, usually the users are not the best at writing prompts, right? And we also saw that the LLMs have a lot of restrictions in terms of the number of input tokens, the total number of tokens, and all those kinds of things. So the users will also have a lot of restrictions. Users will also have a lot of restrictions in terms of like this, they will not be the best at doing things, right? That's the way to look at it. If they enter a very big input, what will happen? You will have to incur very high cost. Also, their input may not be of the best quality. So it may not be a high quality input. User prompts may not be very good quality. And if the user prompt is not of the best quality, what will happen? The accuracy of the results will be impacted. These are all real problems. These are all real problems that you have to address. And now, how do we solve it? Well, rephrase and respond. So what you can do is you can have the original prompt, whatever user is writing, take the original prompt and rephrase that prompt, maybe in 100 words. So we will use one more large language model to take the original prompt and we will rephrase the original prompt and create a new prompt. And then we will use that prompt and use it in the final LLM. This is also a very common strategy that is usually used. So oftentimes you take the original question, whatever the user input or whatever the original prompt is, you take that, you pass it through the rephrase and respond prompt, which is another language model. You can probably take an open source model for this task and you get a rephrase prompt. You take a rephrase user input. You get a rephrase prompt, which is smaller, which is shorter, which is more accurate, right? You get a rephrase prompt, and now you take that prompt and then you give it to the final LLM. This is how you make the final GPT API call. You can see there are two layers we are actually using. The first layer was used to take the original user input and rephrase that into, let's say, smaller number of words, and then you use another the final language model to go ahead and yeah, you take the final language model to go ahead and we are effectively using it for this task. That's the way how this works out generally. And this is what we relate to as represent. Represent respond is also a very useful strategy, especially in scenarios where you have like we were discussing about this use case in the beginning, where the users will ask some question. The users will ask some question, and there are limitations in terms of the platform. There are platform limitations in terms of how big a input you can accept, because there's always a limitation and a limit in the context window, right? So you cannot have a very big context window. There are a lot of limitations that we will have in the real world. Okay, so what we need to do is we need to go and uh, look at it. We need to go and look at it, the user limitations, and rephrase respond prompting will work very, very well here. Okay, so you can have an original user input. The user input, let's say, can be 10,000 words, 20,000 words, whatever original input the user gives. and the rephrase and respond prompt will take the original user input spanning 10,000, 20,000 words, and it will rephrase that into only 100 words. And then based on those 100 words, the final thing will be taken. So that's how these kinds of things work. Because you have to understand it's always a trade-off, right? If you, let's say, imagine that you're building a customer-wise, a company-wise chatbot. Okay. If you tell that users can only enter 100 characters or 100 words, it's limiting the user's potential, right? You're actually not creating a very good experience because users want to enter a big prompt. You don't want to limit the users. Okay, so one option is you straight away give a character limit. You say, okay, maximum you can enter 100 words. You give an input token limit. The other option is you allow the users to enter whatever they want to. Users can enter a very, very long text. They are free to enter whatever they want to. And then you can add a rephrase and respond prompting where you can rephrase that into a slightly summarized prompt, which is more concise, more accurate, more in line with what you want to get answered. Okay, and that is what you can feed to the final language model to get your final response. So this is a very, very common strategy that is usually used. The end users will not even know that their original query is going through multiple layers because they will just see, the input is going and they're getting a response, but they will have no idea, in terms of this working out. All right. So this is what rephrase and respond prompting is, and this pretty much wraps up this notebook. We will continue the conversation on this once again uh, in the next discussion. And there are a few other things that we will talk about, and we'll take it forward from there. The last part, I think we will just discuss is something called self-consistency. This is the last one that I will talk about, self-consistency. Very simple. And self-consistency prompting is nothing but based on a user prompt, based on a user question, we ask the LLM to generate multiple responses. Okay, so based on the user question, we ask the LLM to generate multiple responses. Let's say in this case, we ask the LLM to generate 3 to 4 to 5 unique responses. And based on that, we take the most common or the average response. So that is how this approach will work out generally. So self-consistency prompting actually works out very well, usually in cases where, so this works out very well, usually in cases, in scenarios where I would say we are dealing with very factual applications. Especially in cases where we are dealing with very factual applications, self-consistency prompting works out very well. In factual cases, factual applications where, let's say if you ask the question, what is the capital of India? Now we know the answer is supposed to be Delhi, but we know that these are also uh, word completion engines. We know these are word completion engines. So because they are word completion engines, sometimes the answer can be Delhi, sometimes the answer can be Bangalore, sometimes the answer can be something else. So there's errors. Language models are inherently, they can sometimes make mistakes. You have to keep it in mind. They can often make mistakes also, right? All these language models can sometimes make mistakes. So self-consistency prompting is a way to uh, prevent hallucinations from happening. So especially for factual applications, what you ask it a question, you give it a prompt, and based on that prompt, you generate 3 to 4 to 5 unique responses. So you ask it a question, that means you give it a prompt, you generate 5 unique responses, and based on those 5 unique responses, you choose the most common response. And that's the way how self-consistency prompting works out. So let's say even out of those 5 responses, if 4 are correct and 1 is not correct, let's say out of those 5 responses, 4 are correct. In 4 cases, the model says, okay, Delhi is the capital. And in 1 case, it says Bangalore is the capital. The most common one will be taken. So that is how, on an average, self-consistency prompting will give you the best answers, accurate answers. It is little slower because it's more compute intensive, but it will generally be more accurate because the LLM is going through multiple steps, right? So that's the idea how self-consistency prompting will work out. You can see that you ask for a set of n distinct responses, in this case, 3 distinct responses. And out of those 3 distinct responses, pick and summarize the most common response. So you ask it a question, you say n equal to 5. So you ask the language model to generate 5 unique responses. And out of 5 distinct responses, you pick the most common one. You pick the response which is the most common, and this is the summarized response. So in this case, let's say if I ask the question, what is the capital of India? So even if 4 of them are correct and 1 of them is wrong, the more accurate one, the summarized one for the Delhi one will be taken. So even if one of case the LLM gives the wrong answer, overall, out of the five responses, it will give the correct answer. So that is the way how these kinds of things are used behind the scenes. So we as end users, we may not even be able to see all this, but this is what you develop in the prompt. This is all in the architecture. When developers are prompt engineers are creating the prompt, they're creating the prompt design. They are trying to create all these layers like rephrase, response, self consistency, temperature settings, a few short examples. So we are only as end users, we are, let's say, using the chat GPT application. We have no idea what is hidden beneath those layers. We are simply sending a user input and we are getting an assistant response, but we have no idea what are the layers that are working behind the scenes generally. Okay. All right. All right. So I think we will pause at this point in time, and what we will do is we will carry forward to the next module. So next conversation will be on, we look at some applications of how these prompt engineering techniques can be used for different tasks, particularly classification tasks, generation tasks. We will look at different tasks where these prompt engineering techniques can be used, and and from there, another very important discussion area will be retrieval augmented generations or RAGs. We'll also talk about RAGs and retrieval augmented generation, another very exciting topic area. So that's going to be the next part of our conversation.